Uh, Good morning, everyone. My name is Engineer Christopher Vituk, and this is my submission for the BIM competition for project category ASEAN infrastructure. Yeah, the project that I'll be presenting entitled Construction of Pumping Station, Sewer Main, and Substation at Chuacukang, Singapore. So the content of my presentation, yeah, there will be a short introduction of myself, the company, the project, the BIM usage, and lastly will be the BIM productivity assessment and the benefits. A little bit narration of myself. Currently, I'm on 21 years practicing civil engineering, both here in Singapore, Philippines, and in the Middle East. I've been practicing BIM for about 10 years now, which includes 6 years of that involving virtual design and construction. Graduated at English University Foundation in the Philippines. Studied and completed my specialist diploma in BIM here in Singapore in 2012. Then I went to US, Stanford University, to complete my virtual design and construction advanced management program. Yeah. At the moment, I am currently taking up my master's degree in construction engineering and management. It's an online course in Mapua University in the Philippines, and also doing my specialist diploma in computational BIM. Yeah, also affiliated with the Singapore Institute of Building Limited here in Singapore, American Society of Civil Engineers, Japan Society of Civil Engineers, Institute of Engineers Singapore, and other institute affiliated to ASCE and the Philippine Institute of Civil Engineers. Yeah, I'm also an ASEAN engineer registered. I think I was conferred in 2016, if I'm not mistaken. Yeah, 2016 or 2017. But I believe it's in during the time in Palawan. Yeah. I'm also a part-time adjunct lecturer for BIM management at BCA Academy here in Singapore. Also a BIM lecturer for MDIT College in the Philippines for digital project management, and a volunteer mentor for PICE Visma. So the company which I'm currently employed with is Charju Construction Private Limited. Was founded in 1979. We specialize in advanced earthworks, roads construction, drainage construction, sewer line construction, bridge. What else? Anything involves infrastructures. Yeah. We also do some bioengineering works and other landscaping. So about the project, just to what do you call this one? Because of the time constraint, I didn't manage to get approval in time for other projects which are we recently completed. So I decided to submit a more later project, which is this one. But anyway, I hope this is adequate enough for the competition. Anyway, this is also a very good project, a very good example of the usage of BIM in a contractor's perspective. Yeah. By the way, I will not be also discussing regarding the cost benefits because it's a little bit sensitive, and I didn't get the approval discussing the cost on the cost part benefits. I'm sorry for that. Yeah. So for this project, it was actually I think completed in 2014 or 2013, if I'm not wrong. So during that time, BIM It's just starting here in Singapore, and it's not really mandated yet for submission and on project level. So my company decided to implement Beam early without the government requiring it to be implemented. So it's a this structures is a pumping station, uh, comprises of architectural, structural, and a lot of MEP. Roughly, the gross floor area is about 3,330 square meter. Heavy. It's very heavy in mechanical elements. So the beam use are based on the objective, on what the project teams to be on what the project team wanted to achieve on the project. So basically, the selection of softwares and the implementation of beams are based on the objective on how we can, how as a contractor, uh, we can deliver this project effectively and on time. Yeah? So these are the objectives. Uh, One of the objectives is to create an intelligent model that can extract quantities, visualize the design intent, because most of the time engineers are having a hard time understanding the project just simply by basing it on a 2D drawing. Yeah. And our objective also is to come up with an adequate sections within that structure and produce numbers of sections so that our engineers can and the site people can understand and can be used to coordinate with other subcontractors and foremans, yeah, supervising the projects, detect classes and discrepancies in the design, um, detailing of temporary works, including the design, provide 3D PDFs or markups, and as will documentation. So based on all of these objectives, we decided to use this four main softwares. So for the 3D authoring tool, we use Revit for modeling the architectural, structural, and MEP elements. We also use Revit for extracting quantities, 2D drawings, and produce visualization materials. For class detection and for the simulation, we use Navis Work Manage. Uh, for earthworks, we use Civil 3D. For PDFs, we use Bluebeam Review. So in generating the 3D models, actually what we implemented is not a single model beam. We actually have multiple beams and then we just federate them. One reason why we did that is because during that time, and also it's the same practice today, is because models contains a lot of information and we don't want to overstress or to what do you call this one, to test the capacity or to choke the capacity of your hardware. So as a practice, as a good practice in Beam, you have to try to separate or federate the models into different disciplines, sometimes levels or area. Okay, so but Revit is quite good in in streamlining this coordination and collaboration, even if it involves multiple teams. There is a function in Revit that allows the other user to be notified when there are some changes being made on on other disciplines. So I think that that's the other advantage that we found we find very useful in this process is the notification part. Before, if you're working in a silo, uh, in a silo environment, sometimes architect do some changes, and the notification will come, or you will be informed of the changes not that fast. So you cannot react properly. There's a latency in the reaction of those changes. So by using this kind of tools, it's help us streamline those coordination and collaboration. We also use the beam models in Revit to extract quantities. These quantities are being used during progress claims, a final count. Some other quantities are being used in purchasing, especially like concrete. Yeah, this which is very useful. One more thing about quantity takeoff, took away the burden for QS. We believe the most stressful part on the job of the QS is to quantify all these quantities, and instead of focusing mostly on the rates and sourcing out of quotation, most of their time are being spent on quantity takeoff. So that part alone, you when you take out the thing that struggles them to perform their work, uh, it makes them more efficient in pricing all this uh, quantities. And then we also use Civil 3D for this part of the topography and earthworks. On your left side, if you can see here, let me just pick up my pen. Yeah, this one portion here. If you see, there are a multiple range of colors. The red one actually represents the highest cut that we are doing. The green color portion will be representing almost the flat surface, and the uh, cooler colors represent the backfill. This is the cut. Yeah. So in these tools, actually, it helps our site teams and the project managers and the planners also to properly understand the nature of the existing topography and how will they spread out the cut throughout the site, and minimize the ways of disposing and importing of materials. Okay. And also we use all these things to quantify our volumes. The software also can easily provide us with a table so that they can verify all the quantities. Even though your client doesn't know how to use the softwares, there are sections that we provide as well, extracted from the 3D model. Yeah. And we can also overlay this topographic survey to Revit so that we can see how it overlaid to our structure, and further design some what they call this one, earth retaining structures during the process of excavation. It also help us design our earth control measures, or ECM. Yeah. So we also utilize our BIM model in planning our uh, excavation works, or other works that have a high safety risk. So if you can see, I'm supposed to present a video on this part, but because I could have found in our shared drive the video, the 4D simulation, or the timeline on how it is being constructed. Luckily, I still have the snapshots of all those what we call this on all those sequence. So on the left side here, you can see how we plan it virtually before the start of the projects. Uh, it actually helps the client to approve our method of statements, and at the same time, it guides our site engineers and foremen in the execution during the actual in the actual execution. So we are doing it. We are doing the planning virtually first, and if everything's are okay uh, and safe, we are actually then we can implement it on the site. Yeah, this also help the safety teams, plan their safety uh, plannings on the site, including, if you can see here on the right side of the screen, all the safety access, safety barricades, all those ventilation system, and all those emergency staircase, etc. No, they can really plan this very well before the start of the project by using all this visualization tool. And also it minimize our waste, especially in the materials or temporary works. Yeah, if you can see here, because some of our engineers are not really a tech savvy guys, we use a Bluebeam PDFs uh, to view our 3D models. So our engineers can use that software, is using that software to review this 3D and make their comments. You can see here there's a video showing that on how easy they can do markups and identify all those classes as well. And we also avoid as much as possible printing in paper, especially we all know that most of the papers that we use are not that cheap. Most of the time we use A3 as the smallest size of paper for drawings, viewing drawings. We also have A1s and A0s. So yeah. We also use a 3D mobile app. During that time, we are using Beam Anywhere, but nowadays, bringing the model on site are very accessible now, and a lot of softwares are available on the market. If you're subscribed with Autodesk 360 or Docs, then you can actually view them through your mobiles. But during that time, we are using Beam Anywhere. Yeah, as you can see here, it's quite easy to use, and yeah, they instead of bringing a bulk of drawings to the site, they can just use an iPad, a small iPad, or the bigger screen iPad on the site, and they can actually verify all 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 the structures that are being constructed if they really in accordance with the drawings and to the models. Uh, Actually, this application, you can filter out all the elements. If, let's say if you wanted to see only the mechanical components, or if you want to see a particular components, you can actually filter them out for easy viewing. We also do clash detection. Uh, so we import the 3D model from Revit to Navisworks and perform cast detection. This expedite actually identifying all the issues, increase the predictability before we all move into the site. So actually now I think what makes one of the things that um, we change in our process is we spend more time in studying what you call this one in the pre-construction stage. We really spend time studying the drawings, using all the models, all the drawings issued to us, using all this technology, and try to resolve them as early as possible before we move into the site to minimize the waste. So by using all this technology, it allows us to almost predict all the or identify all the issues in the design and be able to rectify them and or redesign them before we even start the projects. So the client is also very happy that it also minimize the variation works. The impact of those clash detection minimizes the cost. If let's say if you just identified all those clashes while the thing is already constructed, let's say if a wall is already constructed and then suddenly you found out that your ducts are punching through a beam or wall, then it will cause a lot of variation. It can implies additional cost for demolition. Yeah, those kind of things. So the report actually can be exported into HTML or an Excel file for proper recording as well. Yeah. So we also use Revit to produce all the drawings, all the sections into as built. Um, Basically, one good thing about in a BIM process, we all know that the traditional process of doing the as built is always at the end of the projects. But while in Revit, actually we are editing or modifying the models once the information came to us by the form of a survey or a report from us, the engineers on site. We automatically update the models, and that model will be as good as the as built already. So every progress, let's say every week or every month, once we updated that model, it's always as good as built already. So by the end of the project, we don't actually spend more time in correcting the model. So most of the time now, we just extract it or change the title block from for construction to as built. That's the only thing that we are changing. But even that changing of from for construction to as built is quite easy as well because we have already a template for that. We just need to insert it to the model, and it will automatically change everything to that. So it's also very dynamic in nature. So here are the beam productivity assessments and benefits that we found in our beam implementation. One of the benefits is, yeah, really it's the increase of predictability of all those design conflicts and discrepancy. It really is a game changer. It keeps our planning in the construction very efficient. We do a lot better in collaboration. Actually, beam process really promotes collaboration. Uh, if you will try to implement BIM, it will really force you to really collaborate with other disciplines to make this thing work. Better understanding of the design intent, reduce risk, accurate in quantity takeoff. So most of the time, before our traditional process, before we implement the BIM, there's always this discrepancy between the QS of the client and our quantity takeoff from the contractor side. So nowadays, before the start of the project, we lay down in black and white the terms or the procedures or what quantities are we going to use in finalizing the quantity. So it's better also in implementing BIM. BEP is quite important. The BIM execution plan. So yeah, so once the all parties agrees that you use the BIM model to be your source of information, then everything will be very easy. including the final account, settling of final accounts. It also reduces waste in time, cost, uh, especially in materials, in purchasing materials, generating the quantities from the Revit and using the 4D simulation really help us plan well our sequence of works. Thus, it minimizes the double handling, over excess of material orders, yeah, those kind of things. Of course, time savings. Here are the some metrics that we measured during that time. So quantity takeoff into the traditional current practice versus the beam. Please take note that our quantity takeoff is based on actually when the beam model is already established or completed. So it takes time because during that time consultants are not yet into beam. So there's a time spent in generating the 3D models based on the 2D drawings that they provide us. But if you try to compare them, let's say if the beam models is already generated, actually there are a lot of time saving in terms of quantity takeoffs. Yeah. In drawing production is really very useful as well, especially in generating sections. Most of the time, construction drawings they will give you very limited section drawings, especially if the building is quite complex. Sometimes a consultant will not provide adequate sections, but through the use of BIM, actually it really save us times in producing all these detailed drawings of sections for quantity takeoffs for earthworks. So yeah, I think the most painful part of earthworks are taking off of quantities. So we found out that we have at least 2 day savings using our softwares now. But nowadays, even our surveying works, we in our current practice nowadays, we replace it with drones. Yeah, drones. Actually, drones are quite useful. We convert all those photogrammetry into 3D point clouds, and then just import them into our Civil 3D softwares for volume calculation. During that time in 2013, 2014, we still use manual surveying works, but nevertheless, we we still managed to save some time using our softwares to generate the quantities. Yep. That's about it. Thank you very much. If you have some questions, I can be reached out through this email, chrissay@chaiju.com.sg, or through my private email, personal email at cmv24379 @gmail.com. Thank you very much.